Well, hello and welcome back. We're looking forward to a great night on rational exponents. So let me just kind of review that word rational for you. And you can get it right from the beginning. Kind of box in the word ratio in the word rational exponents. A rational exponent has to be a ratio, something in the form of n over m. For example, 2 to the 1/2. Our exponent is a rational exponent. It's in that form, n over m. 3 to the 2/5. Again, we have a rational exponent, something in the form of a ratio. So before we get too far into rational exponents, let's review the product property of exponents. So we're going to use this quite a bit tonight. So remind yourself that the product property says that if you have a power to a power, you just simply take those two and multiply. So I could say 4 to the 6 raised to the 0 is equivalent to 4 to the what power? If I multiply, that's 4 to the 0, and anybody to the 0 is 1. Example 2. 2 squared to the -3rd. Again, power to a power, that's the product property, which says this is equivalent to 2 to the -6th. Now, we typically don't like to leave negative exponents there, and we move them to the bottom, and we talked about that in our previous video. So I'm going to rewrite this as 1 over 2 to the 6th. And then we could even go one step further and say, okay, well, what is 2 to the 6th? Well, that's really just 2 times 2 times 2 times 2 times 2 times 2. So I would say that's 1 over 64. Example 3, 5 to the -2 raised to the 4th. So again, power to a power, the product property says this is really just 5 to the -8th, which I'm going to rewrite that as 1 over 5 to the 8th. And again, you could figure out what 5 to the 8th is. And then this one, notice it's just power to a power to a power, and you just apply that rule. You just take all those exponents, however many there are, and multiply. So I would say this is equivalent to 3 to the -2 times 2 is 4 times 2 is 8. And again, of course, we'll rewrite that as 1 over 3 to the 8th. All right, so here we go. Rational exponents. It says consider the unit fraction 1 over n as our exponent. And that makes sense because we said rational has to have a ratio, some sort of fraction. So we're going to say let's pretend it's 1 over n. Part A, consider simplifying 25 to the 1/2. Apply the product property to determine 25 to the 1/2 squared. All right, so the product property just says take those exponents and multiply. So hopefully you know what half of 2 is off the top of your head. If not, you could write it down. You could say it's 1/2 times 2, and we really say that's 2 over 1. And we multiply the tops, so that's 2 over 2, which is really just 1. So 25 to the 1/2 squared is really just 25. And again, half of 2 is 1, so it's 25 to the 1st. All right, part B says, now let's rewrite 25 to the 1/2 another way. All right, so what's another way to get 25? And I want you to think exponents. Is something to some power equivalent to 25? Yeah, I'm going to rewrite this 25, so just follow here, as really 5 squared. Would you agree 25 is the same as 5 squared? So I'm basically crossing off the 25, and I'm replacing it with 5 squared, and I still have to the 1/2. So now I can say 5 squared to the 1/2 is really, power to a power says multiply, 2 times a half is 1, 5 to the 1st, which is just 5. So why did we do all this? Well, part C says, what can we say about 25 to the 1/2 is equivalent to what more familiar quantity? So let's go back and take a look at this. 25 to the 1/2 turned out just to be the number 5. Is that interesting? 25 to the 1/2 turns out to be just the number 5. What could you say that's equivalent to? Well, I think a more familiar quantity would be saying that's really the square root of 25. So here's the deal, guys. Eureka! The exponent of 1/2 is equivalent to the square root of a number. Let's get that in our notebook, box it in, do what you need to do. This is a big deal for us. The exponent of 1/2 is equivalent to the square root of a number. So we're going to take quizzes that are non-calculator. So we're not going to let you use a calculator. You should be able to do this math in your head. Now, why is that important? Obviously, your SATs have changed. They are currently going to be non-calculator sections, and you do need to be able to do this. All right, so all you have to remember is that anybody to the 1/2 is really equivalent to the square root. So 16 to the 1/2, let's rewrite it, is really the square root of 16. So you should know 16 to the 1/2 is really just 4. 81 to the 1/2, well, that's really just the square root of 81, and the square root of 81 is 9. 36 to the 1/2 is really just the square root of 36, and the square root of 36 is 6. Okay, now, let's say you forgot that trick. We can go back and say, let's rewrite 16. So I want you to fill this in as well. What's another way to say 16? Well, we could say 16 is 4 squared, and I still have it to the 1/2, and 2 times 1/2 is 1, so I really just get 4. Okay, and that's what that whole previous slide was just showing us, another way to do this. Try it with 81 to the 1/2. How could you rewrite 81? Well, that's really 9 squared to the 1/2. Okay, because I'm leaving that 1/2. Those cancel, they make a 1, and I get 9, which again was the same thing I got there. 36 to the 1/2 is really 6 squared to the 1/2. Again, I'm just replacing 36 with 6 squared. 2 times 1/2 is 1, and I just get 6. All right, so unit fraction exponent rule. If n is a positive integer, then b to the 1 over n is the nth root of b. Okay, so again, we need a nice box. Highlight this. Here's our big deal tonight. If b to the 1 over n is equivalent to the nth root of b. So notice it's not always going to be a 1/2 power. Maybe it's a 1/5, a 1/10, a 1/32. Okay, so here's my corny little trick to help you memorize this. Do you see how the number in the denominator is the name of the root? Okay, and again, that's called a root. So I always think to myself, think of like a flower or a tree or whatever the case may be. Where do you find the roots? The roots are always at the bottom. So the bottom number of the fraction is always going to describe the root. Okay, so no matter what you have, the roots are at the bottom number describes the root. So if I see 8 to the 1/3, I'm saying this is really the root. So this is going to rewrite it as the cubed root of 8. So again, they're going to expect you to do this without a calculator. The cubed root of 8, so I'm looking for 3 numbers that multiply to 8, and I think we're pretty good at that. Hopefully you know that's the number 2. Okay, now negative exponents. We talked about this in our previous video. I'm going to first rewrite this as 1 over 9 to the 1/2. Okay, the negative exponent just moves it downstairs. So now I'm going to say the root is the number in the bottom of the ratio. So I'm going to say this is 1 over the square root of 9. So I get an answer of 1/3. Again, no calculator needed. All right, you try C and D. So pause it, don't cheat yourself. If you don't get it right, that's okay, but pause it and give it a whirl. So C, I said this is the 4th root of 16 because the root's on the bottom. And the 4th root of 16, I need 4 numbers that multiply to 16. Hopefully you just said 2. D, the first thing I did was rewrite it as 1 over 32 to the 1/5. How did I know to rewrite? Well, that lovely negative exponent. Okay, so again, the root's on the bottom, so this is really 1 over the 5th root of 32. Okay, so you should know a number that multiplies 5 times to get 32. I always start small, and hopefully you know that number is 2. So my final answer should be 1/2. All right, well, we're building. We're getting more exciting here. Consider 8 to the 2/3. All right, so part A says fill in the missing blank to evaluate. 8 to the 2/3 is equal to what raised to the 1/3? Okay, so not as tricky as you may think. If I want to get 2/3 as my exponent, and I already have a 1/3, what power would I want here so when I multiply I get 2/3? Well, hopefully you're saying 2. 2 times 1/3 is 2/3. And I would, of course, want to keep my base. So I'm saying 8 to the 2/3 is equivalent to 8 squared times 1/3. Because again, power to a power just says multiply. All right, try this one. Fill in the missing blank. 8 to the 2/3 is also equal to what power squared? Well, again, if I want 2/3, I'd have what number times 2 to get me 2/3? Hopefully you're saying 1/3. And I would keep that 8. And again, would you agree 2 times 1/3 is 2/3? All right. Now it says evaluate 4 to the 3/2 without your calculator. So what we want to do is we want to rewrite it, and we're going to rewrite it two ways, just like we did in the previous two examples. Okay, so 4 raised to the what power would get me 4 to the 3/2. And I can think of two ways. I can say 4 cubed times 1/2. Would you agree that gets you 3/2? 3 times a half would be 3/2. Or I could say 4 to the 1/2 raised to the third. And again, that gets me 3/2. Okay, so now either way, I have to evaluate this without my calculator. And you might be going, oh my garage, what the heck am I talking about? Well, we can do this, guys, because we already know what 4 cubed is. 4 times 4 is 16, times 4 is 64. And 64 to the 1/2, well, that's nothing tricky, because we know this just means the name of the root, and that just means the square root of 64, which is 8. So 4 to the 3/2 is equivalent to 8. Let's try it with this version, 4 to the 1/2 cubed. Okay, well, I already know 4 to the 1/2 really just means the square root of 4, and I'm going to keep my cubed. And I know the square root of 4 is 2, and 2 cubed is also 8. So either way I went about it, we got the same answer. So I could say 4 to the 3/2 is really 4 cubed to the half, or 4 to the 1/2 to the third. So of course we're going to have a rule to go with that. So this is called the rational exponent rule. All right, so again, let's get this down, star it, highlight it, do what you need to do, but you are going to have to do it without a calculator. So the nth root of b to the m is equivalent to b to the m over n. Now maybe that sounds confusing, but again, I don't think it's any different than what we did with the 1 over n. Remember, if you think of a flower or a tree, the roots are on the bottom, right? So the bottom number is the name of the root. N is in the denominator, so it's the nth root. M is up here, so that's my exponent. Now they could write it one other way. Notice they could say the nth root, and they could wrap this all up, and instead of putting the m power inside, they could keep it outside. So write both down and be familiar with both setups here. So evaluate without a calculator. Okay, so again, 16 to the 3/2. I'm going to rewrite it, and I'm going to start with the name of the root. So I'm going to say this is really the square root of 16. Okay, and then I'm going to cube it. So I could put the cube there, or I could say it's the square root of 16, and the cube could go inside. I want you to write both down, because you don't know how you'll see it, but either one is the same thing. Now, just do what's easier for you. Is taking the square root easy, or is cubing it easy? Because again, you don't have the calculator. To me, the square root's a lot easier, because I know the square root of 16 turns into the number 4. So now this is really just 4 cubed. And if I don't know it and I can't use my calculator, just do a little scratch work. 4 times 4 is 16 times 4, 64. The reason I chose not to do this one is because I don't actually know 16 cubed off the top of my head, and that's going to take way too long. But you could do it if you wanted to. 8 to the 2/3. So again, I always start by saying, what is the root? So I'm going to say this is the cubed root of 8 squared. Or you could say the cubed root of 8 and square the whole thing. Remember, it doesn't matter. So now what's easier? Well, again, that's a personal preference. Do you want to take the cubed root of 8 first, or do you want to square 8 first? It doesn't matter. And watch, I'll show you both ways. Let's say we take the cubed root first. So I'm looking for 3 numbers that multiply to 8. 2 times 2 times 2 is 8, so that's really 2 squared, which is 4. Or you could square this first, so you have the cubed root of 64. So now I need 3 numbers that multiply to 64, which is 4. So it didn't matter the order you chose, just do what works best for you. Okay, we'll try 2 more here. 8 to the negative 2/3. So remember, start with that negative exponent and rewrite this. I'm going to say this is 1 over 8 to the 2/3. Oops, my 3's a little sloppy there. Okay, so now I'm going to rewrite it again. This is 1 over the cubed root of 8 squared. Doesn't matter the order you do it. I'm going to take this cube root first. Cube root of 8 is 2. 2 squared is 4. So I'm going to get an answer of 1/4. Try another one. 32 to the 2/5. Root goes on the bottom, so I'm going to say this is the fifth root of 32 squared. So again, what's easier for you, squaring or the fifth root? Well, 32 is a big number to square, so I'm going to take the fifth root. What number 5 times gets you to 32? So 2 times 2 times 2 times 2 times 2 is 32, so I'm going to say this is really 2 squared, which is 4. All right, another one. Number 5. Why don't you give 5 and 6 a whirl, pause it, see what you get, and come back and check it. So again, don't cheat yourself. Pause it, and good luck. So I'll just walk you through my work quick. I rewrote my negative exponent in the denominator. Roots are on the bottom, so I said it's the square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8, so I got 1/8. 16 to the 4/3, I said that's the 4th root of 16 cubed. I don't know 16 cubed, so I took the 4th root first. I found 4 numbers that multiply to 16, so that was 2. 2 cubed is 8. All right, jot these directions down for yourself. Rewrite as equivalent radical expressions. So I want my answer to have a radical in it. Question 1. Let's say x to the 1/5. Okay, so all I'm saying to myself is the root is 5, so it's going to be the 5th root of x to the 1st. So 5th root of x to the 1st. Now, do we really need the exponent if it's a 1? Of course not. So I'm just going to say the 5th root of x. Now watch how sneaky I get. What if I said 2x to the 1/5? Okay, pay close attention here, guys. Who is the 1/5 sitting on? I want you to put a parenthesis around here. That 1/5 is only on the x. If it was around both, the problem would have had parentheses already for you. So notice how I rewrite this. The 2 stays outside because it's being multiplied by the 5th root of x to the 1st. Okay, so this is where they're going to get sneaky. Be very careful. This 1/5 is only on the x. Let me show you what it would look like if it was around both. The problem originally would have said 2x to the 1/5. Now I can say, okay, this is the 5th root of 2x to the 1st. And notice how I kept my parentheses and used the first power in there. We'll try a few more. Okay, I've got 4 more examples written down, all very similar. So take a look at them. This is 8m to the 1/3, 8m to the negative 1/3, the quantity 8m to the 1/3, and the quantity 8m to the negative 1/3. All 4 different problems. So let's take a look at the first example. Notice this 1/3 is only on the m. Put your parentheses around there. If it was on both, it would look more like example 6, where it's already there. So it's just on the m. So when I go to rewrite this, this is really just 8 times the cubed root of m. Okay, example 5. Again, this negative 1/3 is only on the m. So when I go to rewrite this, I'm really saying it's 8 over m to the 1/3, because the negative exponent moves downstairs. So now this is really 8 over the cubed root of m. 6. The quantity, on parentheses, 8m to the 1/3, is really the cubed root of 8m. Now, I can actually break this one down because I know the cubed root of 8 is 2, so this is equivalent to 2 cubed root of m. Number 7, the quantity 8m to the negative 1/3. So notice this is all in parentheses, so I'm going to say that's 1 over the quantity 8m to the 1/3, which is 1 over the cubed root of 8m, which is 1 over 2 cubed root of m. All right, and I got one last one for you. Let's say I said 8m, quantity 8m to the 2/3. Okay, so how does that change this problem? So I'm going to say that's the cubed root of 8m, but now notice, what is my exponent going to be? Now it's of 8m squared. Okay, take special note of this one because this has to get cleaned up quite a bit. Okay, so order of operations, say parentheses exponent, so I'm going to start in here. This is actually squaring everybody, 64m squared. And now I can know this cubed root of 64. I do know the cubed root of 64 is 4. and I'll be left with the cubed root of m squared. So if anything went too fast, pause it, slow down, and try again there. Alright, our next little section is rewrite as equivalent exponential expressions. So highlight that word exponential. We now have to have an exponent in our answer. So if I said the fourth root of x, okay, I can now know I have to rewrite that as x to the what power? Well, remember, roots go in the denominator. So I'm going to say that's x to the what over 4? Well, the exponent here is a 1, of course, so I'm going to say x to the 1/4. If I say the 8th root of 2y, okay, now notice, both of these are in there, so I'm going to say this is the quantity 2y raised to the 1/8. Notice that the parentheses are around both because they're both under that radical. Let's say 4 over the square root of m. Okay, well this is really 4 over m to the 1/2. Remember the square root? Sometimes they don't put the 2 there because you know it's called a square root, and square means the number 2. And then to bring this up to the top, remember that just meant the exponent was negative. So 4m to the negative 1/2. And we'll try one more here. Let's say I said the cubed root of, I don't know, 4x squared. And I'll throw some parentheses around there. So now I can say this is the quantity 4x raised to the what power? Well, the name of the root goes in the denominator, and the exponent is the numerator. So 4x to the 2/3. Alright, simplifying using exponent properties. So we're just going to quickly run through some exponent properties, which hopefully we're good at. When I multiply, I add exponents. So I would say 3 times 2 gets me a quick 6. X, now here's where we got to get tricky, guys. We talked about addition of fractions earlier. When you add fractions, you have to get common denominators. So a little scratch work off to the side. I need to add 1/4 plus 2/3. So I need to rewrite each fraction with a common denominator. And I would say 4 and 3, they both go into the number 12. So my goal, and you should be doing the same thing, is to rewrite this with a denominator of 12. That means this gets multiplied by 3 over 3, and this gets multiplied by 4 over 4. So that would get me 3/12 plus 8/12. I would say that's a total of 11/12. So this is 6x to the 11/12. Number 2, 30x to the 2/5 divided by negative 5x to the 2/3. Okay, so we can do the easy part, the coefficients. 30 divided by 5 is negative 6. Now, when I divide, what do I do with exponents? Of course, you subtract. So again, off to the side, 2/5 minus 2/3. Now you can't subtract, just like you can't add without common denominators. So you ask yourself, what do you want that denominator to be? And we're going to rewrite each fraction. So hopefully your gut said 15. Okay, we've already done this earlier in the year. So I'm multiplying this fraction by 3 over 3, this fraction by 5 over 5. So that's going to get me 6/15 minus 10/15, which is negative 4/15. So I'm going to say this is 6x to the negative 4/15. Now, remember, you're not going to leave it like that because this has a negative exponent, and it's only attached to the x. So this is going to be negative 6 over x to the 4/15. Now, maybe you want to rewrite that as a radical. Maybe that's what the multiple choice looks like. That's equivalent to negative 6 over, remember the root is in the denominator, the 15th root of x to the 4th. So this answer is good as well as this answer. Alright, I've got one more of this type for us before we move on. 2x to the 1/4 cubed over 2x to the 1/5. Alright, so now we've got 3 properties going on here. The first one says everybody gets cubed. So watch how slow I take this. I not only have to cube the 2, but I also have to cube the 1/4, or x to the 1/4. So I'm going to say, okay, 2 cubed becomes the number 8, and power to a power is multiply, so 1/4 times 3 over 1 is 3/4. Whoops, I forgot my x. Divided by 2x to the 1/5. Okay, so if you got that part, I think that's the hard part. So slow down and pause it if you need to. And now we'll go ahead and divide. 8 divided by 2 is 4. And when I divide, I have to subtract. So off to the side, 3/4 minus 1/5 Common denominator looks like a 20. So this gets multiplied by 5 over 5, 4 over 4. So that's 15 minus 4. So I'm going to say x to the 11/20ths. Or that could be 4, the 20th root of x to the 11th. Well, that does it for us tonight. We're going to get a lot of practice with this tomorrow in class. So bring your A game, and we'll see you then. Have a great day.